Plugging into the quadratic formula, where we can solve this quadratic equation. So using my quadratic formula, x is equal to negative 2 plus minus square root of negative 2 squared minus 4 times a times c. And that's all over 2a. And so simplifying this, we get 2 plus minus square root of 4 minus 36, or square root of negative 32. Now we cannot square root negative 32, so there's no solution. Okay, or no, I should say no real solution. There are imaginary solutions for this. So why does the quadratic formula not give you a solution? It's because we cannot square root. We cannot square root negative values. So what does it look like on the graph? When I graph this expression, I get a y-intercept at plus 9, and I get a quadratic that looks kind of like that. And when we look at the shape of this quadratic, it does not cross the x-axis. So if we have it equal to 0 means y is equal to 0, which is that line there. There is no intersection with that y equals 0. So there's no solution. So there are some quadratics then, because of their shape, they give us no solution. And that shape is related to the fact that it is there is a negative inside the square root, which does not allow this parabola to come down and touch the x-axis. Using this example, we can solve this with a quadratic formula. X is equal to negative 12 plus minus 12 squared minus 4 times a times c. And that's all over 2a. Simplifying this, I get negative 12 plus minus 4 times 4 times 9 is 144. So we end up with square root of 0. And normally we get two solutions. The plus minus usually gives us two solutions. But because we're adding and subtracting 0, really we only have one solution, and that is at negative 12 over 8, or negative 1.5. So why does the quadratic formula only give us one answer? Well, we only get one answer because we are plus minusing the square root of 0, which only generates one solution. Okay, so what happens when we graph this? What does it look like? There's my graph. If I graph that equation, I end up with a parabola, kind of a steeper parabola, but it bounces at negative 1.5. There's a bounce there. It just touches, just barely touches there. And it's because that point of symmetry happens to be where the 0 is. And so the vertex just touches the 0. And this is indicated by the fact that it does not generate the two solutions that we expect, but the one solution at one point. So the two arms are meeting at that same point. So some quadratics, because of their shape, gives us no solutions. Some quadratics, because of their shape, because it just bounces here, gives us one solution. And we can relate these shape tendencies to what's happening inside the square root. So there's a negative square root there and a 0 square root here. So we can see how many solutions the quadratic equation has from the graph, but we can also relate that to something called the discriminant. And the discriminant is this piece inside the square root. So when that discriminant is equal to 0, we are talking about b squared minus 4ac, which is also something we call the nature of roots, or the number of solutions. These are all connected. So in this case here, when the inside part of this is equal to negative, this is our discriminant. And this discriminant tells us something about how many solutions that graph has.